Hi guys, and welcome back to the channel. This video is going to be a bit different than our usual videos in a few ways. Firstly, it's going to be more of an electrical video than an electronic video because we're going to be making up a motor control panel for a macadamia nut processing dehusking plant that gets used at the farm to take the husks off the macadamia nuts before they're dried and shipped off to the factories for further processing. So that's one way the video is going to be different. The second way is this video has been completely shot on a Samsung phone instead of using a video camera. So we're going to see how this pans out. If you are interested in panels and industrial automation videos, I do recommend the channel Cursed Controls on YouTube because that guy does a lot of repairs and industrial automation, PLCs, motor controls, sewage pumps, and you should check out what he's done in his house with all his pipe work and everything like that. But anyway, let's go back to the video. Hope you enjoy. Today we're in the vehicle workshop where you don't really park vehicles because we have to turn this panel or this box into a motor control panel. So we need to have this box with all its metal orange goodness, and all these things have to go in, and a few more. There's contactors, there's overloads, there's switches and everything. So let's get to it. Okay, step one, obviously you have to get the box out of the box. Is out the box now. Still sitting on a bit of cardboard just to protect it. So if we look here, it's a mild steel enclosure with its two latches. Open the door. Then we've got a nice device plate there where we're going to be mounting our contactors and breakers and trunking and everything. At the very bottom we've got two gland plates for all our glands that we need to come in and out, so we're going to have to drill a lot of holes there. And then our door, we're just going to have a basic few switches and an isolator indicators on the door itself. So it's not too bad installation. Okay, so if we look over here, we have got our slotted trunking or our pan duet. That's all the wires we're going to run in. Probably going to go up and around and down the sides there. And at the bottom, just to keep the wires looking neat, we'll see about that later just now. And then we've got the DIN rail that we mount all our contactors and breakers and components onto. So the first thing for me to do is lay out this slotted trunking and the DIN rail just as a proof of concept, just to see how it works, because it's going to actually sit up like that, just so we can see how much space we got in our panel for everything. Okay, so I'm just going to basically measure how long I want this side, and a cut, going to make the other side the same length, and then just go carry on through. And of course drop it on the tripod. Okay. So what's nice about it is having this grid pattern on it. It's so easy just to align things. Okay, now that I've got my left and right space on those lines, I'm not going to pop rivets in now. I'm going to drill and do all the pop rivets one shot. So I'm going to go now and measure this inside gap in millimeters because we are South Africans, not like Americans. 620. Okay, 620 millimeters. We'll cut a few slotted trunkings like that, and then we'll go ahead. So this is basically the rough layout. So you've got the pan duet or slotted trunking going all the way around for your wires to go. Also you've got between all the things, so your supplies will come in here and then come out there into the trunking. I am going to adjust the spacing based on the width of the contactors and overloads, and then repeat and repeat. And then the last row, even if it's going to be this one or one further on, we'll have terminal blocks for them to connect all the motors to. Okay, so now I'm going to start by mounting at least one of the sides and start working my way down, and pop riveting. I learned a while ago not to brush off iron filings with your hand, because they'd like to climb into your fingers, and then you have a badge. Right, now some blind rivets. That's how it's on. Now we'll rinse and repeat a few more times. I'll save you that boredom. Hopefully everything will be mounted, or at least the panduit will, and then we'll work out the spacing for the DIN rail. We'll have the outside panduit first. Okay, so as you can see, this is all the types of components we're going to need to mount onto the bus bar, or onto the DIN rails, right? Okay, we've got the isolator switch. We've got a phase failure supply monitor, we've got a contactor and overload, we've got a normal 10 amp circuit breaker, and we've got a nice distribution bus bar. So as you can see, the one we've got protruding out the most is the thermal overload on the contactor. So I'm use that as a guide. Okay, so I'm just moving this up. See, now that gives me almost no space to the tines or the fingers, so I'm going to go down to the next line. Okay, so if I mount this one here, then that gives me room for wires to come in and out neatly and bend around as they need. So I go here, I'm going back to another closest line, which is there. Should I go further? Yeah, maybe I'll go further there. Okay, so I'm going to basically say that this is my marking here, so I can count the spaces between the top and the bus DIN rail, and from there to the next one, and I can actually repeat, and then just see how it looks first, and see how many rows I can fit in here. Okay, so now all the DIN rails and all the panduits is in place. You'll see this one's got a less of a gap at the top compared to the rest. That's because these are just terminal blocks that go on there, and I prefer to have more gap underneath to route the wires neatly into those terminal blocks. So basically all the contactors and all the other switchgear will go onto those guys. So far so good. And you'll see I've also put a safety earth here, just riveted on. There is earth on the box, but we just want to make double and triple sure. Okay, so this is the order that I want to have the contactors and breakers. So you're going to have this breaker that's going to supply those contactors, and then that breaker that'll supply those three contactors, just to divide it into two logical groups. Obviously I'm going to move that onto the top row, but what I want to do, I want to just put a small little bit of silicon onto the bottom of each breaker and contactor, and then I'll use a little piece of plastic keyring as a spacer basically, so all my spacers are even and the contactors aren't jammed against each other, so if one gets a bit warm it doesn't affect the other one too much. So all I do is just take a bit of silicon adhesive, and you don't need much, it's just to stop it from sliding on the DIN rail. Just one little drop. You need to pull the little tangs out so it clips in. Okay, that's one done. Okay. Go for the next one. I can put it on any side, so I'll put it on the bottom of the contactor there. That's the bottom. Okay, let me just do a few in a row so that I can just clip them all in. This is normal silicon, so it's not quick drying or anything. Just to stop it from sliding and keeping it nice and evenly spaced, especially when I'm connecting wires and that you don't want them shifting all over the show. Okay, so that's each of them with a little bit of silicon. And now, like I say, I've got my breaker in place here. Let me take you around this side. Yeah, so the breaker for the first set of contactors is in place. So now I'm just going to push the contactor down, find my little keyring spacer. Okay, hold it in there and slide it across so it just touches the So it's not too tight there. Okay. Make sure my spacings are all okay, nothing's closed up. It's like a little feeler gauge, this keyring thing. Yeah, that looks good. So that's my first row. Okay, second row is for future, and third row. So second row is for future. Third row, we'll probably have to have our isolator base, our surge protection, breakers, and phase failure relay. Okay, so here we are, all we're up to today. We've got our 2 circuit breakers and our 9 contactors with thermal overload protection. Got a blank section, got another mostly blank section, and then we've got a 4-pole surge protector. We've got a distribution block to distribute our power nice and safely and evenly with nice connections. We've got our isolator, our 3-pole isolator, our 10 amp breaker that's for our control circuit. We've got our supply monitor and phase failure relay to shut down the system if anything goes out of spec. Got 2 nice big beefy earth blocks and a smaller earth block. This will be terminals for a remote emergency stop switch if they need. If it's not used, we'll just bridge it out at the bottom and then leave a note that if they want to connect an e-stop later, they can just connect it up to there. Then over here we've got our 9 outputs for our motors. They're 3-phase motors, so it's L1, L2, L3 and earth per motor. So that's, you'll see that there's 10 here. I've just left the extra block in case because we got that extra blank spot over there. So that's all ready, and then I've got my safety earth as I mentioned before here. So this is just going to let it silicon dry, and then I can start wiring it. Okay, so after a few days on and off, I've just had a few minutes to work on this every now and then. This is what the panel is looking like at the moment. All the wiring in place, all the switchgear in place. So now it is actually time to move it into the box that I've already pre-drilled and mounted some devices on here. So we got voltage indicators for red phase, white phase, blue phase. Yes, South African. We've got a power good indicator if the phase failure relay says it's happy and the supply is all in spec. We've got a trip indicator in case any of the contactors overloads trip. Emergency stop that they can just whack if somebody's arm gets caught in the machine, which hopefully won't happen. And then we've got start and stop for the 2 different halves of the machine with indicator lights. So now I am going to move this panel into there, and then we can carry on. And there's a cat. And okay, just a look at the inside of the cabinet before this back panel goes in, those device plates. At the bottom we've got our gland hole, 25mm for a 10x4 ECC cable. We've got a few holes for normal PVC glands for the wires going to the motor. And then we've got the back of our indicator lights, the back of our start-stop buttons, the back of our emergency stop, and we've got a few stickies to try keep the wire neat. Eventually these stickies do like to fall off, but hopefully it won't be too soon, and I can also secure the wire to here to stop it. So now, let me try. Okay, now let me try get this in there. I've got my nuts and washers on top. My socket set is in my van that's a mechanic, so I've just got a 14 socket because these are not 13 nuts, even though they're supposed to be 13s normally. They're 14. Okay, so I've got this thing balancing. We take the device plate. Yeah, that's good. So let me put Okay, there we go. So that device plate is in. Now I've got these wires that's hanging around here. These are going to go basically to the door. So obviously I need to go put my phone on charge because it's quite flat. But then I will carry on and I'll see you in a bit. Okay, I don't have any spiral bind on me. I thought I had, but I don't. So for the moment I'm just cable tying this bundle of wires going to the door. Always leave a loop. Even if the door can't open more than that, it's just nicer leaving a loop. That way if you do have a damaged wire or if you have something you need to change, you've got a bit of slack. So now what I'm going to do is I'm going to put a few cable tie loops in these little holders and start routing the wire. Let me start with the neutral to all the indicator lights and then I go from there. Okay, I thought before I carry on here, I just want to show you how I'm terminating these control wires, because as you know or may not know, they're stranded wires. I don't know if you can see there, but it's actually a whole bunch of separate strands. Where's the camera? There. Okay. Whole bunch of separate little strands, and you get them in and sometimes it sticks out and it's unsafe and things like that. So what I'm using here is called bootlace ferrules. Okay. Let's see if I can focus on this. Okay, so it's a little insulated ferrule with a little exposed copper thing. And here is a double one. So this is for 1 1mm panel wire. And this is for 2 1mm panel wires. So you'll just push them both in. Or in. And then you use a crimper like this that gives it a nice square crimp. Don't know why I'm looking like a smurf. But anyway, so let me show you now. So here's my neutral. It's going to come to this indicator light first. So we're going to go down, do a nice gentle loop there. And bump you guys around. Okay, so I'm going to cut this wire here. Okay, let me bring you right in so you can see what I'm doing. Hopefully I won't forget it to here. Here I'm looking blue. Okay, so all I do is I'll put it in the stripper. The stripper is just before the screw, and I pull it like that. The stripper does a nice job because I've set the depth so it doesn't damage the coppers. Okay, so now you see I've got 2 strands. I can either twist them together first, or I can just hold them together and push them into this ferrule. Okay, let me give it a little twist because I saw the strands are jumping around. Now it wants to be difficult now that I'm doing this on camera. Okay, so I've pushed them right there. You can see we've got a tiny bit sticking out the tip. So now I'll just put my little crimper in there, crimp it, and you should be able to see it's got nice square edges. If that side is a bit too long, just crimp it. Then what's nice as well, if this is jumping between a few different fittings, so it jumps from here to here. Say I need to change this globe, well, this LED assembly, sorry. I don't have to worry about the 2 neutral ends coming out and then one of the neutral ends being live, because it keeps the circuit even if you pull this one out. So let me go connect up all the neutrals and I'll see you in a bit. Okay, so there you can see my neutral is looped between all the indicator lights. Once I tighten these cable ties, it will look a lot neater. But yeah, basically it loops through all the indicator lights. Now I am going to use my very meticulous notes. So I'm dropping everything on the floor. These are the notes that I took when I was busy wiring the back panel there. It's like the wire with 1 mark is red voltmeter, white voltmeter, blue voltmeter, power good, and so on and so forth in that. I do have a diagram that I drew up actually after starting to wire this panel. But this just tells me which wires are going to the door, what they are assigned to. So let me start wiring those up. So if I look, it says wire number 1 is red. So it should be one of these 3. Yeah, there we go. So these 3 are bundled. You see I've got 1 stripe there, 2 stripes there, and 3 stripes. So this will be red voltmeter. over there. 2 will be white voltmeter, 3 will be blue voltmeter, and so on and so forth. I'll see you later. Okay, so here's the front panel wired up in all its glory. Okay, I still do need to cut a hole in the bottom of the panel, around about there somewhere, for the isolator's handle to go. And also need to cut the trunking covers and put the trunking covers on the panduit. But because of noise and it's quite late at night, I will obviously do that tomorrow. But how about we give it a shot and see if it works? Okay, now I don't have 3 phase in the workshop here, or in the garage, so let me show you what I've done. If you look on top of the isolator, I don't know if you can see there, I've just bridged across between all 3 phases, then connected it to a normal single phase circuit. Then at the bottom here, I've got the supply monitor over here, which is going to complain because it doesn't have 3 phases in the right direction. So I've just taken the input to the supply monitor's contact and I've bridged it straight into my emergency stop circuit. So that should, in essence, bypass that supply monitor and let it run on single phase, and the panel should act okay because our control circuit just runs on 1 phase. And because I bridged everything together, we should actually see the lights for all 3 phases. So let's switch that on now. It doesn't matter if we put these power circuit breakers on or not, because that doesn't matter. Okay, now we close the door and maybe drop the whole box. So as you see, I've got a bit of straightening up to do. 250, 250, 250. So those volt indicators, hope you can see them. It's going a bit closer. Yeah, I do need to straighten them, but I'll straighten them when I do put the labeling on, saying what they are. So that's showing 3 pseudo phases, just not normal single phase. That says power's good because I bypassed that supply monitor. No contactors have tripped. Emergency stop out. Should we first see what happens if we trip and overload? Yeah, I found a better screwdriver, so I'm just going to push the testing. Everyone should be tripped, so we should have an indicator light saying it's tripped, but we don't. Okay. Try another one. Okay, I heard that one click. Okay, I just didn't push it hard enough. Okay, so now we've got a trip light. That's good. So it's telling us at least one of the motors has tripped. Let's hit reset. And reset. And it's happy again. So let's try start the first line. Okay, I heard the contactor cluck. And we've only got the first 3 contactors. 4, 5, and 6 are off. Okay, let's try the second line. Second line, first 2 contactors, and the third contactor is off. And also I don't have any indication. That's why I haven't connected up the live. I connected up the neutral to those indicator lights over there, but I haven't connected the live up. That's why we don't get indicator lights. But let me do, it's been a bit of debugging here. Okay, I've just removed the overload so I can get to the A1 and A2 terminals that's under this contactor, because the A1 and A2 on the top pass right through to the A1 and the A2 on the bottom. So if I get power on the bottom, then I know I've got power coming in through the coil. Because it will pass right through, well, coming into the terminals there. So A1, A2, and you can see I've got 250 volts, 248, 249. So it looks like it could be the coil on this contactor that's faulty. Well, there's only one way to find out. I'm going to rip it out. Maybe this could be the problem with the first circuit as well. Over there, showing you over there, open circuit. So it looks like the coil is not working in this contactor. Let me put another one in for my stock. We'll see. Okay, so let's give it a shot now that I put the new contactor in there. Whole circuit on. Push the button. There we go. All three pull in. Let's check this one now. Again, we've only got those three pulling in, not this one. So let me pop this lid up here. The way these are working, if I push this one, it should let those two kick in. Yes, so those two are running fine. It's this one that isn't pulling in. So let's see. Remember to switch your voltmeter to volts AC. AC. Look at that. Another contactor with a bad coil. Let's see if I've got a spare. Right, here we go again. First circuit. Oh, that was nice. Second circuit. Stop, stop. Listen to how they all chatter one in after the other. Because this one starts up. Then as soon as this one pulls in, it lets this one pull in, this one pull in, this one pull in, this one pull in. So each one lets the one next to it pull in. So you hear, I'll not that one because that's only 3. Makes a nice purring sound. And then let me push the emergency stop button. Everything drops out. And it won't do anything until I twist and release the emergency stop. Okay, so that's good. Now let me just do the indicator lights. Wow, sorry. Okay, so we're ready to test. I've connected up the lights, even though you can't see it because I put the wire into this bundle. I also changed those white cable ties to black because I know it was triggering some people. So let's close it. And that's wrong. I picked up my live from a maintain part, obviously after the e-stops, my indicator lights, instead of from the output of the first contactor. So I'm supposed to be picking up from the output of this contactor, auxiliary, normally open, and this one's, oh sorry, this one's normally open. Let me fix that. You learn by doing. Okay, so what I've done now, this normally open, or this output of this auxiliary contact, feeds to 95, which is the overload for this next contactor, which only pulls in when that one is. So that's where I've tapped my lights onto this feed from that auxiliary basically, and also the one this side. So should work. The same thing I said last time. Okay, so e-stop is out, lights off, that's good. Lights on. Lights on. Got a bit of a flicker there as a contactor switch, but that's probably just back EMF. E-stop kills the whole circuit. Cool. So now just the trunking covers, the labels, and the hole for the isolator. Okay, I thought I would show you how I'm going to measure where to drill the hole for the isolator. That's kind of a tricky thing sometimes. There's a shaft that comes with the isolator switch. So I just need to put the shaft in. Okay. Then it's easy enough. You just get a tape measure. Not inside, it's on top. And because the side of the door lines up with the side of this cabinet, I can just measure to that. Easy, eh? Okay. So 135. So 135. 135 from the side. Just making a note on a piece of cardboard here. Just double check again. 135, close enough. From the ground, and just remember this is lying down a bit. So it does have a little room to go up. 145. Or if I straighten it up, 150. So 135 by 150. Wonder where that's going to land us. It's not going to land us into the lock mechanism on the side, or this the rail on the door. Okay, 135 by 150. So 150 is over here. 135. Hey, almost exactly right. I'm going to pull 135. So that should be the center of my unit. So I got this plate here. 135 just clears that plate. That's nice. So I'm going to take the handle apart. Handles apart. So this part's going to basically mount on the back of this metal plate, and this will mount on the front. Go a bit further. You can actually pop this apart, and there's your holes that you can use to mark. You can even take the little rubber gasket off. And let's see if my marker, yeah, my marker pen will go right through there. So I'm just going to line that to the center of the cross. I'm going to mark one dot, one corner, or one screw hole. Try and make it level with the box, because I can't use a spirit level because it's not level. Because I'm balancing it on speaker. So 115, 115. So I make the second dot, 115, and because those two are aligned now, that one will be, and that one will be. So it's easy enough. 4 or 5 mil holes there. And then a nice, say, 20 mil hole through there. Then I can mount the switch in nicely. So if they do need to shut it down, they can just turn the switch off and then they can open the door. Cool. But as I said, that's for tomorrow because we can't make any noise. Check later. Okay, so here's the panel all put together. I'll just move it into this other corner so I can leave it running on test for a few days, make sure that nothing fails before we take it and start installing it on the equipment. Because the isolator is in place now, we have to switch the isolator off before we're able to open the door. It's interlocked for safety. So there's all the labels, warnings, labels on the output so they know where to connect all the motors. And basically that's it. Okay, I thought I'd show you just as they're busy doing the mock setup and that to take it down to the next province. So here's the panel on a nice bracket that they've made. There's a sorting conveyor belt with a motor on the end over there. It's a tumbler that lets the nuts go through and fall through the holes. Dehusker that goes and takes the husks off the outside of the macadamia nuts. As you can see down there, there's samples that we were testing with, macadamia nuts and their husks. And then that's about it. Oh, I forgot, here's the drying blower. Let's switch it on, let's see what noise it makes. Okay, I'm not going to start the sorting table because then my toolbox is going to go for a walk. There's the tumbler tumbling, the husker spinning. So now they can take this and go put it in. In case you're wondering about that hole, there's one modification that they want. They want a separate contactor for that fan, not on the dehusking circuit. So that's going to go in over there, and I'm going to have a on-off selector switch in the panel here. Then all the wires just connect it underneath. Thanks for coming along as we built up this panel. I know it is a departure from the normal electronics things, but still, I hope you learned something. I hope you enjoyed it. If you did, do the normal like and subscribe, and I'll see you next time.